Hello everyone, I'm Dr. Shaik Ruksana Begam, working as Assistant Professor in the Department of Electrical and Electronics Engineering in Institute of Aeronautical Engineering, Hyderabad. Today we are going to solve more problems on nodal analysis. So if we see in the previous lecture, we have discussed about nodal analysis. First, what is a node and how to calculate the voltages by using nodal analysis, and what are the steps used to calculate nodal analysis we have discussed in the previous video. So before starting the more example problems, now I'm going to tell you first what is a node. So in the previous lecture itself, I have told you what is a node. So node is nothing but combination or joining two or more elements at a single point is known as a node. So here we are having three elements which are joined at a single point is called as node. So generally nodal analysis is used to calculate the voltages. So what are the steps used to calculate nodal analysis means? First step, we have to identify the nodes in the circuit and choose one node as a reference node. From the nodes whichever we have identified, from that we have to choose one node as reference node, which is also called as ground node, which will be the voltage across that ground node or reference node will be equals to 0. And then third step, we need to apply KCL at each non-reference node. So this is the reference node. A part of this node, we have to apply KCL, stating that the sum of currents entering into a node equal to the sum of currents leaving it. So we already know about KCL. KCL is nothing but the currents entering to the junction should be equal to the currents leaving out of the junction. The same rule will be applied in the nodal analysis. Coming to the fourth point, use Ohm's law, which is I is equals to V by R. Generally, V is equals to IR is the formula for nodal analysis. Now here we are going to calculate the currents by using nodal analysis. So I will be equals to V by R. So we have to write the equation in terms of I is equals to V by R to express branch current in terms of node voltages. And finally solve the resulting system of equations to find the nodal voltages. So finally from those equations whichever we have written in the form of I is equals to V by R, we have to calculate the nodal voltages. So in the previous lecture we have solved problems by taking only one node. By considering only one node, we have solved problems in the previous lecture. So in this lecture we are going to consider two or three nodes and how we are going to calculate the node voltages by using two by using two nodes. So first step of the nodal analysis is to identify the node voltages. So if we see this problem in the circuit shown in the figure, determine the node voltages. So for this circuit, we have to determine the node voltages by using nodal analysis. So the first step of the nodal analysis will be we have to identify the nodes. So from the nodes, we have to take one reference node. So if we see, I have already told you the node is nothing but joining of two or three elements at a single point. So here is one element, here is one element, and here is one element. So it is joined at this point. So it will be taken as a node, which will be denoted with V1. So it's your wish, you can denote it as V1, X1, or it's your wish. So as if we are calculating the node voltages, I am denoting it as V1. So next, here also the three elements are joined at a single point. So this is also I am taking as node and it is denoted with V2. So a part of this nodes, here I am taking one node as reference node. So this will be taken as reference node which will be equal to 0. So this will be the reference node. Apart of this nodes, we have to calculate the node voltages by using KCL. So now if I write the nodal equation for this circuit, first I am considering this part for first voltage and then this for second voltage. So as if I am calculating for the node 1, I am writing the equation as V1 minus, so the voltage across this will be of 100 by the resistance across this element will be of 15 plus next V1 by 20 plus V1 minus V2 by 5 will be equals to 0. All these equations I am writing in the terms of I is equals to V by R. So this is the voltage and this is also the voltage. So I am taking it as V1 minus 100 and the resistance in between these 2 points will be of 15 ohms. And then by considering this element, so the voltage will be of V1 and the resistance in this point will be of 20. Again, by considering at this point here V1 minus V2, so it is connected, the 5 ohms resistance is connected in between V1 and V2. So I am taking it as V1 minus V2 by the resistance will be of 5 ohms. So now I have completed for the node 1. Now I am going to write the equation for the node 2. So this will be considered under node 2. So if I am going to consider this node, then I am writing the equation as V2 minus V1 by 5 plus V2 by 30 plus V2 by 5 will be equals to 0. So why I have written this equation means now I am considering for the node V2. So for the node V2, the elements whichever are connected is 5 ohms, 5 ohms and 30 ohms. So if I consider this 5 ohms is connected in between V2 and V1. As I am considering for the node V2, so first I have taken V2 minus V1 by the resistance in between V1 and V2 is 5 ohms. And then if I consider for the element 30 ohms, V2 by 30, and if I consider for the 5 ohms, V2 by 5 will be equals to 0. Now I am going to calculate the values of V1 and V2. Before calculating, first we have to separate the values of V1 and V2. So this equation can also be written as V1 by 15 minus 100 by 5 plus V1 by 20 plus V1 by 5 minus V2 by 5 will be equals to 0. So now I am taking out the common terms. That means V1 I am taking out, V2 and V2 also I am taking out. V1 into V1 is 1 by 15 plus 1 by 20 plus 1 by 5 minus V2 into 1 by 5 minus 100 by 5 will be equals to 0. So now I'm going to calculate all these equations, all this, and I'm going to write in the form of equation. So now after substituting all these values or after solving all these values, we are getting the equation as 0.3166 V1 minus 0.2 V2 equals to 6.663. So this will be considered under equation 1. Now I'm going to solve equation 2. So equation 2 can also be written as V2 by 0. Now I am taking out the values of V1 and V2. So minus V1 by 1 by 5 plus V2 into 1 by 5 plus 1 by 30 plus 1 by 5 will be equals to 0. Now after substituting these values, the equation can also be written as so this now this after substituting these values or after solving these values, we are getting the equation as minus 0.2 v1 plus 0.433 v2 equals to 0. So now I am considering this equation as equation 2. After solving this equation 1 and 2, in mesh analysis I have already mentioned or I have already told how to solve the equations by using scientific calculator. So in the scientific calculator, if we go for the mode setup, we'll get option 5 as equation. Then by equations, if we are having 1, 2, 3 or equation, depending upon that, we have to select the equations and we have to substitute these values in this calculator. And then we'll get the values of V1 and V2. So after substituting the values in the scientific calculator, we are getting the values of V1 and V2 as so V1 we are getting it as 29.729 V and V2 as 13.7319 volts. So in this way we have to calculate if we are having more than one volt, that one node. Now in this problem we are having two nodes. So by using this method we have to calculate the node voltages by using nodal analysis. We have to write the equations in the form in the terms of I is equals to V by R. So moving to the next problem. If we see this problem, in this also we are having two nodes as three elements are connected at a point and here also the three elements are connected at a point. So first we have to denote these nodes as V1 and V2. So if we see here we are not having any resistance. Here the ammeter, that means current source is connected across this resistance. Now how to calculate if there is a current source in the circuit? So we are going to discuss in this problem. So first V1 node will be taken as it is as shown in this previous problem. So first we have to write the equation in the terms of I is equals to V by R. So in terms of V by R, we are going to write it as V1 minus 10 by 1 plus V1 by 5 plus V1 by 2 equals to 0. Sorry, V1 minus V2 by 2 equals to 0. So in the same way, we are going to write the equation 2 is V2 minus V1 by 2 plus V2 by 10. So as the current is flowing upwards, the direction is minus 2 equals to 0. So again we have to take out the terms of V1 and V2. So I am writing the equation here, V1 by 1 minus 10 by 1 plus V1 by 5 plus V1 by 2 minus V2 by 2 equals to 0. In the same way for the second equation, V2 by 2 minus V1 by 2 plus V2 by 10 minus 2 equals to 0. Now we have to take out the terms of V1 and V2. So first for V1, it will be of 1 by 1 plus 1 by 5 plus 1 by 2. Same for V2, it will be of minus 1 by 2. And then minus 10 by 1 will be equals to 0. So for the other equation, we have to take out the terms of V2 and V1. So these two equations have been written in this way. So V1 terms we have taken out, V2 terms we have taken out, remaining is minus 10 by 1. And then for the second equation, V1 is 1 by 2 and V2 terms we have taken out, and remaining minus 2 I have written as it is. So after substituting all these, or after solving all these values, we'll get the two equations as, so it is of 1.7 V1 minus 0.5 V2 will be equals to 10. The second equation will be of 0.5 V1 plus 0.6 V2 equal to 2. So after solving all these equations, we'll get the two equations as 1.7 V1 minus 0.5 V2 equals to 10, and minus 0.5 V1 plus 0.6 V2 will be equal to 2. So these two equations I'm considering it as equation 1 and 2. Now we have to calculate the values of V1 and V2. So in the same way, for as we have calculated for the previous problem, we have to substitute all these two equations in the scientific calculator. After substituting the values, we'll get the values of V1 and V2. So after substituting the values, we'll get the values of V1 as 9.09 volts and 10.91 volts. So if you are having a current source, we have to calculate the equations in this way. So this 2 amperes I have taken directly in this equation. So as if the current is flowing in the upwards direction, I have taken it as minus 2. As the direction of the current is in the downwards, I'll take it as plus 2. So remember, if the direction of the current is moving downwards, then the value will be taken as plus 2. If the direction of the current is in the upwards, we have to take the value as minus 2. So after solving these equations, after taking out the values of V1, V2, we are getting the equation in this way. After solving these two values, we are getting the equations as 1.7 volts minus 0.5 volts equals to 10, and V1, sorry. So after calculating this, after substituting these values in the scientific calculator, we'll get the values of V1 and V2 as 9.09 volts and V2 will be as 10.91 volts. So coming to the third example problem. So while solving mesh analysis problems, I have already told what if there is a current source in parallel with a resistance, how we need to calculate. So I have already told you, by using the source transformation technique, we have to solve this circuit. If we are having this circuit in this way, it will become more complex to solve the problems. So first we have to reduce this circuit by using source transformation. If a current source is connected in parallel with a resistance, we have to convert it as a voltage source in series with a resistance. So to convert this, we are using the formula V is equals to IR. So we all know that the Ohm's law formula is V is equals to IR. By using this, we have to convert the current source into a voltage source in series with a resistance. So the I value is given as 8 amperes and the resistance is of 10. So the value of V will be of 80 volts. So after conversion of this circuit, we have to redraw the circuit again. So it will be easy to calculate the node voltages. So after conversion, the circuit can be redrawn in this way. So we have got the voltage as 80 volts. So I'm connect as the direction of the current is moving moving in these. So the direction of current is moving in this direction as the source is also taken as positive and negative. So the voltage is 80 volts and resistance will be as it is, it will be of 10 ohms. So for this we have to calculate the node voltages. So I have denoted the voltages as V1 and V2 as if there are three elements connected to a point, and here also there are three or four, more than three it can be connected. So more than two elements whichever are connected to a point is known as a node. So here also we are having a number of elements connected to a single point which I have denoted with V2, and we have to take one node as reference node. I am taking this node as reference where the voltage will be equals to 0. So from this we are going to calculate the node voltages by using I is equals to V by R. So as here we are going to calculate the node voltages, the equation can be written as V1 minus 100 by 8 plus V1 by 4 plus V1 minus V2 by 2. And then for the node 2 I am writing as V2 minus V1 by 3 plus V1 by 3 plus V2 minus 80 by 10 plus 5 is nothing but 15 equals to 0. So here also a source is connected. So I am taking it as V2 minus 80 by these two resistances will be connected in series. So I am adding these two resistances. 10 plus 5 will be of 15 ohms. Now we have to take out the values of V1 and V2 for the both equations. I am writing it as V1 by 8 minus 100 by 8 plus V1 by 4 plus V1 by 2 minus V2 by 2 equals to 0. This is for the first equation, and the second equation will be written as V2 by 3 minus V1 by 3 plus it is V2. V2 by 3 plus V2 by 15 minus 80 by 15 will be equals to 0. So now we have to take out the terms of V1 and V2. So if we write for V1, it is of 1 by 8 plus 1 by 4 plus 1 by 2 minus V2 into 1 by 2 minus 100 by 8 equals to 0. And then for V2, so minus V1 1 by 3 plus V2 1 by 3 plus 1 by 3. I'm sorry, here it is of 2. And then so it can be written as 1 by 2 So I'm taking out the values of V1, V2 for both the equations, and I'm going to calculate all these equations, and then I'm going to write the two equations. So the two equations can be written as is after solving these equations, solving the values of V1 and V2, we are getting the equations as equation 1 as 0.875 V1 minus 0.5 V2 equals to 15 volts. This will be considered under equation 1. And then for the equation 2, minus 0.5 V1 plus 0.897 V2 equals to 5.33. This will be considered under equation 2. So after solving these two equations, we'll get the values of V1 and V2. So the values of V1 and V2 will be of 25.94, and the value of V2 will be of 20.4. So after substituting the values in the calculator, we'll get the equation. We'll get the values of V1 and V2 as 25.94 volts and 20.4 volts. So in this way, we have to calculate the node voltages by using nodal analysis if we are having more than one node. So in the previous class, I have told you how to calculate the node voltages if we are having one node. One should be taken as actual node and second one will be taken as reference node. So in the same way, if we are having two nodes, we have to take one as reference node and two as actual nodes. So from that we are going to apply the equations in the form of I is equals to V by R, and then we have to calculate the node voltages from these equations by using nodal analysis. That's it for the today's lecture. In the next lecture we are going to discuss about the theorems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.